Good afternoon, friends. Welcome to the STP training webinar series. The topic for which today is Zero Automation to Zero Fear in more than 0 minutes. Our speaker for the day is Brian Fitzpatrick. I'm Smita Mishra, a professional tester myself, and I'm excited to host you all and Brian on our STP webinars. Quick information for all of you. The next upcoming conference we have is Fall 2019 STP Con, which will be held at Boston from September 23rd to 26th in 2019. The keynotes have been selected and announced, and you can look them up at stpcon.com. We have the world-famous automation leader Angie Jones, the automation and testing leader Dorothy Graham, a world-renowned speaker and a bright technopreneur, Kevin Suresh, and finally, we have the hugely popular testing leader, a mentor to many, and our very own Mike Lyles as the keynote. We are still going through the review process for the sessions, and the entire program will be soon up for your selections. If you plan to attend the upcoming conference, don't forget there are various discounts and offers for alumni attendees and team registrations. Should you have queries, do email them at info@softwaretestpro.com. There is other information that I have for you. There is an upcoming webinar, Keys to Effective Test Automation in DevOps, on 12th June. The speaker is Lee Barnes, who's the founder and CTO of Utopia Solutions. The discussion will touch on key practices and methods for implementing effective test automation in a DevOps pipeline. The link is up for you to register. Please go for it. And if you are on Twitter, please share the conference information and about this webinar with your followers, connections. You can also add STP's Twitter handle to your tweets, which is @SoftwareTestPro. All right, let's get started with the webinar today. A very warm welcome, Brian. We are very thrilled to have you with us today. And let me quickly introduce you for all of us here. So Brian Fitzpatrick is a quality engineer at Gannett with a focus on bringing testing and development closer together, with a major part of his responsibilities being helping others become more involved in the testing process. Along with Thomas Dale and Scott Gunter, he has developed the model-based testing software simulator to further push efforts around the union of developers and testers. Okay, testing people, let's get started with the discussion on the basics around the transitioning to DevOps and the real-world challenges we are facing in doing so. Very warm welcome again, Brian. And the floor is all yours now.
Thank you so much. Hey, everybody. Let me click this real quick. All right, thanks again. As Smith said, I am Brian Fitzpatrick, and this is Zero Automation to Zero Fear in 60 minutes, or with respect to your time and lunch hour, probably more 40-ish plus Q&A. So just quick introduction. As was mentioned before, I work for Gannett, which is part of the USA Today network. Many different journalists and newsrooms around the country and a little bit past the country as well, with lots of different digital projects to support. And because the news is breaking, and unfortunately software oftentimes is breaking as well, we just cannot have those things happen at the same time. So in order to prevent that, we focus a lot of efforts around quality and automation to make sure that that is kept to a minimum whenever possible. Don't want to harp on that too much though, so let's get straight into it. So what is automation? I'm sure a lot of you have ideas around what automation might be, but just to have a consistent definition throughout the talk today. My definition is taking a known process and replicating the path of that process, and then implied a little bit to have similar results each time. One thing that's important with automation is not for the sake of replacing manual tasks. So there's a lot of different things that you can focus on when deciding what to and what not to automate. But whenever there's something that is easier and a part of your work process to just do manually, generally that's not a good candidate for automation. So with all this, we have the perpetual question of what is the testing problem? A lot of the points today are going to be focused around business requirements. And one of the big testing problems we face is costs. What are our costs of maintenance? And in another unrelated realm, but still a part of the problem, is the complexity of our testing. So cost and complexity within software oftentimes scale directly with one another. So as our complexity goes up, our costs for maintaining that complexity and maintaining that software go up as well. And we want to try and stifle that as much as possible. And that's kind of where our automation comes in. So getting started with that, there's a couple of different questions that you guys can kind of review and on your own, think about your own situations as to what sorts of things we might want to move towards with automation. So one thing is, what types of projects do you have? And that's not the specific details of your project, but rather, how does it reach out and touch your business? How does it affect the workflow and day-to-day lives of others throughout your business? For example, for us, as I mentioned, we do media and news. One of our big projects that we support is our content management system. Obviously, that is very critical to the entire business. If that goes down, then there's not much news to deliver. So things like that, how crucial it is, those are the sorts of things you want to start thinking about when you think about what projects you might want to automate. Another thing is, what is your current testing strategy? While automation doesn't have to come from a previous testing strategy you might have had, manual or otherwise, it's very good to know what sorts of things you are going to be jumping into. So if you have any sort of current testing strategy, mapping that out along with the projects that you're thinking you might want to work with is very helpful. And finally, what resources do you have available? This isn't strictly just money or time. It's people's time, people willing to automate, people able to automate, people willing to make that change in their career. There are a lot of different things that can influence that. The necessity of a project, the lifespan of a project, many other things as well. But that's something that you definitely want to consider when automating, because again, this is all about making sure that we are making the best investment when we're moving away from some of our manual testing and into automation a little bit. So what sorts of things make for good automated testing? One thing is regular releases with known user interactions. So if you are releasing regularly, then that means you're probably running regression against your software regularly, which means you are using X amount of time, the amount of time that it takes for all of your tests to run, times the amount of releases, and that would be high if it's regular releases. So if you're taking the time to automate this, it's a good investment because it's something that you're regularly interacting with. The known user interactions bit of it helps with creating those paths, because as I said, for our definition of automation, we want to replicate that process. So if we know that a user is logging in, filling out some field, and then logging out, that's something that's very easy to automate because it's something that we're going to be able to replicate and always understand what the results should be. Second one's a little bit more complex. It's software with lots of black boxes or poor architecture. Not that those are necessarily the same thing. In the software industry as we know it, there are a lot of black boxes just because people are coming and going. There's so many different dependencies across different software that others may know about or may not know about. So from your login function to your entry function, there may be 600 different pieces of the software that you don't fully understand. And that's okay. That's not necessarily poor architecture. It could just be agile architecture. But what's important is that we understand if those pieces that we don't fully understand are interacting in the way that we expect them to. So when you have these automated tests and you're running them every time you make a change somewhere else in your program, you know that in those sections you're not fully sure on, any abnormal behavior is still recorded because the other pieces of your program are responding as expected. So that kind of takes away some of that uncertainty in those areas. But coming back a little bit from the complexity around that, there's also some simple processes, which, as I said before, login, enter data. Those are also fine for automation because it's all about saving time at the end of the day. And if that's something that you would have to do over and over again, it's something that your computer could do in 10 milliseconds. So lots of time savings. But with all the good, there's some bad or difficult things that you need to automate. So what are those sorts of things? Random patterns, as I mentioned before, interactions from the user, as expected, are nice to have because then you can actually generate consistent tests. But if you don't know exactly how something is going to go down, then it makes it a little bit harder to automate. And that might be something that you might want to do exploratory testing or still continue just your manual testing with. Another one is paths that build from previous input. So if there are multiple steps to your test and it relies on certain conditions being met in the past, those might not be met by your other tests. So it would be hard to truly automate those. We do have a strategy that we implemented ourselves that I'll talk about a little bit later. But generally, this is something that would make just writing manual test scripts a little bit difficult. And then the last pain point is tasks that have a lot of timing or loading. If you're making a lot of I/O calls or network calls, any latency around that is always going to give you flaky test results. And unfortunately, there's not a great way around that. That is still something that can be automated, but it's something that you might actually save some more effort by just manually going through that. So I talked a little bit about testing strategies earlier, but what exactly are those? So there's a bunch of different types of testing, as I'm sure a lot of you know. There's performance testing, there's end-to-end testing, there's accessibility testing, and all of these different types of testing are great and fine and all. Do you want 100% on all of them? Well, that really comes down to your business requirements. So unfortunately, we aren't able to just maximize everything as much as possible. We're trying to use our resources as efficiently as we possibly can. So the types of testing that we actually want to implement need to be most closely to what we need from our software. So if we have a system that we want the quickest performance from, we want just the most performance system possible, then you're going to be doing a lot of performance testing, and maybe some of the other features might not matter as much. If you have another system that needs a lot of uptime but may not need to be the fastest program in the world, then you might do a lot of testing around maybe even chaos testing, because for those unfamiliar, chaos testing is basically forcing variables into your environment and seeing how your program reacts to it. If somebody enters an invalid username into the login box and it takes down your website, maybe not the interaction you want. Chaos testing kind of helps us reel that in and find those sorts of weaknesses in our software. And those are the sorts of things that would be dictated by the business requirements. And following up on that, the coverage and depth of testing is also very closely tied to the business requirements. It's somewhat arbitrary in the way that we decide how much we want of the depth and coverage. But again, it really it's determined by how much you can spread yourself with the resources that you have. So the benefits of quality and development is the primary one, increase in maintainability of projects. So as I said before, this is an investment. You are putting in more work to make sure that the frameworks are there to exist and support the infrastructure of your tests. It is less time in the future that you will be going through at the last minute trying to make sure everything's lined up and set to ship. Because you are continually doing this, you're going to have less downtime for production, which, back to business requirements, I don't think you could ever tell a manager, hey, we're going to have less production downtime, and they'd give you a frown. I think that's always going to be good. And one of the slightly less known things is it's more capitalizable work. So for your different companies, you will actually have capitalizable work around writing tests and developing code. However, bug fixes and maintenance are not covered in that. So the less time you can spend on bug fixes and maintenance, the more time you can spend on capitalizable work, and the more your manager will most likely be happy with you. So where do you start is another question. So evaluating your situation can really break down into a couple of different stages. These bars aren't fully scaling with one another, so it's not a manual to stage 1 as you're doubling it, or from stage 1 to stage 4 you're quadrupling your progress. These are just the different stages and separations. So let's say you're at manual right now. How do you get to stage 1? Well, you can start with some test scripts. Writing some test scripts, and I will show you how to do some of this later, will just help you rip back some of the manual testing that you're doing on tasks that aren't fully necessary, that they're good automation candidates, and running those in conjunction with your regular manual regression will save you a lot of time, and it will really kickstart you into the realm of automation. If I had to give it an arbitrary number, I would say you're probably more than 40% of the way there if you just have your test script suite prepared for your automation. Then you move into more of a stage 2, where you have infrastructure for managing those test scripts. So you're no longer sitting there and running your test scripts in conjunction with your manual test. Instead, you've set up some sort of infrastructure to run it for you. This is the CI/CD part that we'll be talking about a little bit later. And this is probably 75-ish% the way to fully automated. By stage 3, we have automated tools for generating test scripts. This is the last thing I'll be talking about today, which is advanced testing techniques. It is a tool that we have generated ourselves around model-based testing, which basically lets you input how you expect your program to behave, and then it generates the test for you. The benefit around this is that you are less involved in the generation of the test cases themselves, and rather you provide the data that you expect your tests to need, and then in an unbiased way the tests are generated so that you get more coverage and better tests. Finally, in stage 4, which is the future for us too, don't worry, we're not quite there yet either, it's producing tests from production data to best serve your needs. So when you combine all these things together, you get a truly fully automated test suite, and that you are taking your production data to target the areas that you need for your business requirements, and in a hands-off way, you are running them against your software throughout the development process. This is going to give you the strongest and most consistent response to any sort of bugs you might encounter. So I've talked a lot. Now I want to show you guys a couple of examples around the things I've kind of been talking through. So the automated process, unfortunately, this is more the manual process still, but you have an action and a system and test and the results that come out at the end from it. So this is just your manual test process. The automated test process is not very different. Basically, you have a set of actions that runs into your system and test, and then your report of results is produced instead. You can do whatever you want with that report. There's a lot of variation. But the idea here is that you're basically just replicating the actions in a way that you don't have to manually execute them every time. Sorry, this bar is a little bit in the way. I'm trying to set up for the demo here. So a couple of different automated test suites we've used. We started using Nightwatch JS a couple of years ago. We're moving more towards Jest now. For those unfamiliar with Chai and Mocha, Chai is in assertion suite. So if you've done any sort of automation around tests before, it's the assert that such and such is true, those sorts of things. There's a large library around it. And there's a lot of documentation around their site itself. But to show you an example of this, I'm going to bridge off into a quick demo. Oops. Of course, as per usual with demos, everything's going great. No There we go. Okay, so here's our sample Nightwatch test. So we have very simple test here. We're going to traverse to Google. We're going to wait for the body element to be rendered, and then we are going to assert that the title is Google. Pretty simple. This assertion is the chai assertion I was talking about earlier for those unfamiliar. So to quickly run this, we're just running Nightwatch against the test sample test. And this will happen really fast. So it checked that the body was indeed rendered, and then it checked the title, and both assertions passed. Cool. That's all there is to that. For Nightwatch, there's a little bit of configuration around it. For those unfamiliar with JavaScript, there is a slight bit of a learning curve. Your package JSON file and your Nightwatch JSON file are basically your configurations for these suites. They have a lot of documentation around it on their website. Unfortunately, in time allotted, won't have time to go through full setup, but they do have a nice getting started around all this on their website. I'll have links at the end if you would like to get involved in that. A lot of this stuff is very well documented, so you can quickly interact with all of it. And finally, you will also be able to learn more around the development process if you're interested in that by doing this sort of automation, because you're going to be getting closer and closer to the code, and that will kind of lead you in that direction. So not a ton with this. Nightwatch does provide a lot more tests in their examples. So to give you an example of how you could save a lot of time, if we ran all of their tests, that's just time. That's all time you're saving if you're not running all these manually. So these are just checking various CSS values, checking if pages load, checking latency, other things like that. There's a lot of different stuff that it checks throughout their full suite. Yeah, so that's just fine. We don't need to watch through all that. So yeah, that's some of the stuff around Nightwatch. That's just having an automated suite with all of that. It's pretty exciting. I will field some questions on that later. I'm going to roll straight into CI/CD portion now, though. So what is continuous integration and continuous development? A few years back, I had no idea what the answer to this question was. I Googled it a little bit, and I still had no idea what the question was. So I worked on it for about 6 months. I still barely had any idea what I was talking about. I think I've gotten closer, though. So with continuous integration, it's really about making sure that your suite of tests is essentially a part of your development and release process. The continuous delivery comes in when you take that release and then push it to your customer, your internal services, wherever it needs to go. So to think of it this way, a developer creates something for a feature release. Then the manual tester needs to review any of the changes and vulnerabilities that might be brought about by that feature release. Once the manual tester is done with their testing, they create some feedback around the release, either thumbs up, great, go ahead, successful release, they push it out, go to whatever the next part of their process is, or it goes back to the developer and then they repeat the process. The problem with this is, well, if you're limited on manual testers, then this will constantly be blocked on it. Generally, our manual tester ratio isn't 1-to-1 with developers. So if we have 15 developers per manual tester, that means for every release that any developer does, they're all blocked by that manual tester. And we enjoy our manual testers. We don't want to torture them. So what we would like to do is take away the stuff that they that isn't really necessary for them to do. So that's kind of where CI comes in. So CI is basically a task runner to really 500-foot view this. It lets us do different small tasks, including taking those automated test suites and run them against the builds. So say a developer creates their feature release now, and they push this to your shared code repository, let's just say GitHub. You can have a couple of CI builds kick off on that push to the code repository, and it will give them instant feedback on the testing around their release. This then can still follow the same cycle of going back to the developer. But the nice part about that is that it no longer is chokeholded by the manual tester, and it's not putting constraint on them. Instead, it's just a very simple cycle that the developer can keep to themselves. And then on successful release, sure, you may want to take a final review of that, but that's going to be much more gracious with the manual tester's time than every single time any change is pushed to go through the whole manual process. So there are a couple of different continuous integration platforms we have out there. Jenkins is the one that we have been using for a while now. Travis is also one that we use for our open source tool Simulato. Concourse is using Kubernetes with continuous integration. I would say in terms of getting started, the easiest one is probably Travis. If you are familiar with more of the coding spectrum, just because it's basically just a file that integrates with the software you already have. If you are a little bit more familiar with the DevOps spectrum, then Jenkins is something that you probably want to move towards. Basically, you just set up your own Jenkins server and then put instructions in there in the form of a Jenkins file, which I'll be talking about in 5 seconds, that will let you build out all of your different tasks. So for Jenkins in particular, as I mentioned, configure your builds from the Jenkins file. The Jenkins file lives within the code repository, so when code is pushed, that is the sort of thing that will be kicked off. It references other things within the code repository itself. If you're familiar with CSS at all and cascading style sheets, how they stack with each other, you can do similar things with the Jenkins files where you have like one base Jenkins file and then a couple of other different Jenkins files that build off of each other. The nice thing around that is that you can have different configurations for your different builds, and you don't need to worry too much about just having like one universal project for everything. The other nice thing about that is if you are a little bit cautious about getting too involved with Groovy script, which is what Jenkins file is written with, your developers may be able to help out with that, as it's, again, very close to the code. So it's something that the development team can really interact with. The task runner that it has is for different plan stages. So if you have a build your app stage, then it does the build app, but then you also may have a post stage of after the app is built, post some artifacts to some area within your company space, then you can do that. That way you can continually build and produce the things you need without worrying about having intermediate steps. And then finally, configurable for deployment to incorporate continuous delivery. This is where you can start pushing out your builds and not worrying so much about where things are coming from. You may still want to lay off on the continuous delivery for something that is a breaking change. This might still be something you want to go through a manual review process for. But if it's just a routine push for a weekly build that everything is passed, then you can just push that right out. It just saves you a lot of hours around your resources on that. So the last thing I want to talk about is some advanced testing techniques, or technique in particular, model-based testing. Yes, it is very branded because this is the logo we came up with. Simulato is a model-based testing framework that we created over the past 2 years or so. And what model-based testing is, for those unfamiliar with it, is you have your system in test, and you take that system in test and define it over a course of models. Each of these models, or components as we call them, describe the behavior of your system in test. When you take all these models you've created and push them into our software to generate tests, then out comes the test produced from those models. So in this style, you're no longer writing the automated test as we did with a Nightwatch test. Instead, you're just simply describing your system as you see it. Benefits around this are that you're going to see more significant changes in the ways that you're testing things. Instead of testing just the things that you're thinking about, you'll be testing things from an unbiased perspective of the interaction of the models with one another. So that's a lot to take in. I have given a much longer presentation on how model-based testing works than a minute. So take a second for that, and I will try and do my best to explain it a little bit better with this quick demo. So to show you what a model looks like a little bit, this is our model. So again, for those of you unfamiliar with JavaScript, sorry, this might be a little whimsical looking, but fortunately, JavaScript objects are also very much so readable in English. So when you think about the brackets in this sort of thing, they just enclose with each other. So the top bracket goes with the last bracket, the second bracket goes with the following, et cetera, et cetera. So it just is a breakdown of what sorts of behaviors we expect. So don't worry about this node modules or module exports thing. That's just defining the object as a whole. And we're saying that we are going to navigate to the test site. This is our entry component. So for the different models, this is one that is a starting model essentially. And then once we get into it, we navigate to the test site. In this case, it is just running locally. And then we have a couple of different things that we expect. We expect that there's nothing there except the main site layout. And that's just kind of how all these models go through. We take the elements of the page that we care about, we arrange them into a model, and then we create any actions that we expect those things to do. So for example, give it a second. So this is USA Tomorrow, very creative name, don't worry. This is just our super basic test site for the acceptance test around our tool itself. This is what we're looking at. And we want to generate acceptance tests. So from the models that we are, the components we have here, we've generated a couple of different actions that we expect to happen. And then we can just run those tests. And sorry if that's a little bit fast to see still, but basically it just goes through, clicks on the article, confirms that it sees what it thinks it saw. And it's very similar to the test scripting that we talked about earlier. It runs the same sorts of assertions and makes sure the same sorts of things happen. So that's basically model-based testing in a 5-minute nutshell. Again, there's a lot more around that, so don't feel too bad if that was a little bit confusing. I just wanted to bring it up as something to mention. Okay. So to conclude, I'd like to kick it over to any questions if people have those at this point. And I will leave this slide up for resources if you guys are interested in any of the things I talked about today. They all have quick start guides and tutorials around the different types of technology.
Okay. Thank you so much, Brian. It was a very insightful session on model-based testing and how do we transition to DevOps. Okay, we do have a couple of questions. So the first one is, How is chaos testing different from random testing or fuzzing?
It's a form of random testing, I believe. I am not the perfect expert to speak on this, sorry. But I believe that chaos testing is seeking failures essentially and how you respond to those failures, whereas random testing is testing things within the realms of your program still working as intended. So for like example, like chaos testing would be like unplugging your database, whereas random testing would be like giving it a random value that you might not expect, like for like sanitization purposes or something like that.
Mm-hmm. Okay. And there's another question that is there access to USA Tomorrow test site?
Yeah, that's also it's not very complicated. It's right in the documentation around Simulato. It's part of the package, so if you're running the thing as a whole, that'll come along with that. And that's all open source, so feel free to look through any of that stuff if you guys are interested in that.
Very nice. Okay, the next one is, how did your team transition from manual to automated testing? Uh, like new resources or trained existing ones? Any thoughts around that?
Yeah, so I've actually been here since close to the beginning of our transition to automation at Gannett. Um, I was hired as a contractor 4 years ago, I guess, um, to help Greg and his automation effort. He is our director of quality engineering, and he has really brought everything from nothing to where we're at today. Um, Back then, like I said, I honestly did not know what CI was at all. That was what I came into the first day. He said, "Hey, we're trying to get this thing started." Um, a lot of it is just kind of picking away at it. I'm sorry, that's not exactly the best advice, but there's so much documentation around all of the different pieces. There's so many quick start guides. If you have any questions about any technology, generally just going to their site and following any of their documentation or just their quick start guides will help out. Granted, that is not a universal concept. Some things don't have the best documentation, but for most of them, there's at least one tool probably for everything we use that would have another simpler version of it. So if you feel like any piece is not really coming together, just look for another tool because there's another one that will help.
Mm-hmm. All right. The next one is, do you know of any model-based testing frameworks which can generate tests for different interfaces from a common model, like browser or for mobile apps, an API, for example?
So to keep talking about our own thing, Simulato can do this. Future things that we plan on implementing are adding other drivers, so like having an API driver. Right now we're just using WebDriver, so for an interface, that's a perfect thing that we would use this for. We use this actually for UI testing within our content management system because it's a very big content management system with a lot of different branches. So we really need to account for all the different possibilities. And as I said before, that's not always possible with with regular automated test scripts. So we do have their tutorial, the test I quickly ran, that would show you basically how to go through the interface portion of it. Um, I believe there's a C++ variant called GraphWalker. I'm not sure if they have API integration yet, but that is something that we're working on. Just another thing around that too, if you guys have any needs or use cases of Simulato that you guys are interested in, feel free to throw GitHub issues up. We're always happy to look at those and hopefully expand in ways that people need the tool for.
Mm-hmm. Um, There's another question that is, does the entire QA team take part in maintaining the automation framework?
So that kind of depends on how you break up the team. So for our configuration in our team, uh, we're trying something new right now where we have separate squads for different teams to have a more hands-on service to really integrate with the different development teams throughout our company. Um, but from those separate teams, we have the same core teams. One of them is infrastructure, which I'm a part of, which really works on maintaining the frameworks and the development around that. And then a secondary team of SDETs, which focuses generally on creating the tests and solutions around that. And then a third team of specialists, which focuses on the exploratory and manual testing. So it's not necessary that everybody's fully involved in the maintenance of the frameworks, but it really just depends on what resources you have available for it.
That makes sense. Okay, the next question is, what are the kind of skill sets that testers need in DevOps environment?
It's going to sound a little bit cheesy, but the willingness to learn. It's a lot of fortitude around it. Like I said, you can find stuff out there. There's always guides. Other people have always had your questions. Very, very rare that you will have your own unique question that nobody's ever asked before. Sometimes things aren't always just going to work right out of the box. The problem with that is that why things don't work isn't always clear. And it is very frustrating when you've been working on something for 3 days and you realize it's because on line 6,458 you forgot a comma. But just really fortitude, sticking to it, and just continually looking through guides and expanding and learning. That's really the best way to get into it.
Mm-hmm. Here is a question. So in your response to the question prior to this one, you mentioned about the three categories of people. And so the question here is, what size is your QA team versus engineers and developers broken out in those three categories you mentioned?
So our exact number for developers, I am not 100% sure on. We have, for the teams that we're supporting directly right now, I think it's around 50 developers or so for the team that I'm supporting directly. And then for the other half, they are supporting a team of, I think it's around 20. I could be wrong. My team is about 8 strong, and the other team is about 4 or 5 strong. Broken down into, for our group, 2 specialists, 2 infra, and 3 specialists. 3 specialists, 2 infra, and 3 SDETs. So for developer to SDET, it's like 3 to 40, and then for the other team, it's about 1 or 2 to like 15ish. So generally, it's around the number I said earlier, where it's like 1 to 15 isn't really a huge surprise. And yeah, it's unfortunate because that's kind of the way that companies prioritize a lot of things right now. Quality is often seen as a second thing, when it's really one of the biggest valuable things that you can really incorporate into your build process.
Mm-hmm. And do you typically, so this is a separate question from the same person, do you typically build automated tests in parallel with developers or following release to QA and manual exploratory testing?
So it's a little bit of both. So with Simulato, we've tried to train developers to be more part of the model development process. The nice thing about models is that, as you guys saw before, they're very close to the code. It's very much so generated in a way that you would generally program. It also gives you the benefit, which I didn't really talk about earlier, of having a stronger architecture around it, because when you are generating a model before you actually write the code, you are basically making a blueprint of what you want your code to do. So you're really breaking more into test-driven development when you're doing that. And that's kind of where we want to be in our relationship with our developers. We want them to understand the tools we create, and we want our tools to be useful to them. That being said, with new tools, there's a lot of efforts that need to go in from our end to make sure that they're well received and usable.
Mm-hmm. Thanks. Where can we find courses about DevOps?
You tell me, and I would be very happy now.
Yeah.
So companies are generally going to have internal documentation around that if they already have that. Unfortunately, this workshop was around talking about what if you don't. From my experience, we fortunately had a couple of people from our platform engineering team that had some experience around that, but a lot of it is going to just be finding stuff online. If you have specific interests that you want me to try and look into a little bit for you, I haven't really searched through all the documentation recently, but I could probably put together some packet if people would be interested in that. Just feel free to reach out to me.
Okay. Yeah, one could look into maybe platforms like lynda.com. Mohan Srinivasan just contributed that, so thank you, Mohan. Okay, here is another question there. There have been many discussions in the testing community about whether a tester in automation or technical role should be also doing manual testing. Many believe that you are either manual or you are automation. What are your thoughts on this?
This kind of ties back into what I was saying earlier about resource allocation. So if you have somebody who can do something and cannot do something else, not ideal, but unfortunately the way the world sometimes, then like you need to have them do as much of the thing that is limited as possible. So like in my current role, because I'm kind of one of the few that do a lot of the infrastructure stuff, I don't really get as much involved with the manual testing end of things anymore. When it was not as dependent on me, then yeah, I was much more involved in that. But I think it's very important to understand both because they are all part of the same workflow. So if you try to ostracize manual from automation, you're not really getting the most efficient automated tests you can because you're not considering why manual might be more valuable in certain situations.
Mm-hmm. Makes sense. All right, here is our last question. Do you recommend a Java class, like Java training class, to have the knowledge to start with DevOps?
So I'm actually asked this question a lot, not just in particular to testing, just from a software development perspective as well. I think if you're trying to learn anything and you think classes are the best way that you've learned things in your life, then go for it. It's going to be very similar to everything else that you've ever done. It's going to be similar to a math class, whatever other thing you've done. But if you feel like classes are not the most effective way for you to learn something, just pick a project that you want to work on. Pick any language, it really doesn't matter which one, and just try and do it. So if it's something like a calculator, something really simple, right? Just try and make a calculator in a Java calculator, for example, if you're interested in Java. That would help you significantly because then you would be looking at all the different branches of not just theory around how you might use the language, but also the implementation of the language and actually interacting with the language. It's a little bit complicated at some points, but hopefully it'll really get you immersed in the topic as opposed to just thinking about what you might want to do instead.
Well, thank you, Brian. Actually, it was a good interactive session. And thank you for sharing all the details and the tool details too. That really helps a lot. I'm sure our attendees found it very informative and useful. So thank you again, and I hope to see you at STPCon soon.
Yeah, hope to see you as well. Thank you, everybody, for attending. I appreciate your time. And if you have any follow-up questions or whatever, feel free to reach out to me directly.
Sure. Well, everyone, this concludes our webinar for today. Thank you for joining, and more importantly, thank you for being engaging and making the most of the webinar for yourself and the whole group. And if you want to see more sessions from speakers like Brian and others and wish to learn more about testing, definitely join us at STPCon Fall 2019. Like I said, the keynotes have been selected and announced. Do take a few minutes to look them up at stpcon.com. The entire program will be soon up for your selections. And if you have queries on registrations, do email them at info@softwaretestpro.com. Stay tuned for more webinars and online trainings coming soon at SoftwareTestPro.com. And if you haven't yet signed up for the upcoming webinar, which is Keys to Effective Test Automation in DevOps on 12th June, please do so. The speaker is Lee Barnes, who is the founder and CTO of Utopia Solutions. The discussion will touch on key practices and methods for implementing effective test automation in DevOps pipeline, including test suite and test scope, automation approach methods, and test environment and data management. So if the topic interests you, please register for the same at SoftwareTestPro.com. Thank you, everyone. Have a great week ahead, and see you all in Boston in September. And keep practicing your testing skills. Thank you.